Hello all, time for another podcast this week on the global heat budget and other lessons. So, in terms of the global heat budget, it refers to the balance between the amount of solar radiation received by the Earth and the amount of solar radiation lost back into space. And this balance determines the Earth's climate. When more is reflected, it is colder. When more is absorbed, it is warmer. There are four components of the global heat budget: solar radiation, absorption, reflection, and emission. Now, different factors can influence the amount of solar radiation, and therefore, different factors can influence the global heat budget. The first one being latitude. So the angle of the sun's rays directly affects the amount of radiation from the sun is received in an area. The nearer the equator you are, it is more direct. You get a greater amount of solar radiation, whereas the higher the latitude, the further north and south, the less concentration of solar radiation, therefore normally colder. And that's why temperature increases with less latitude. Albedo, number 2, so the reflectivity of the Earth's surface and atmosphere. So that's why light-coloured areas such as the North Pole reflect a lot of Earth's surface and atmosphere in the same way a white t-shirt does, whereas by the equator, when it's like the tropical rainforest, that's a bit darker, it absorbs more, therefore reflects less. And greenhouse gases, carbon dioxide, methane, CFCs, and nitrous oxide. The more greenhouse gases in the atmosphere, the more heat is trapped, therefore influencing the heat budget and increasing the temperature. Now, 23% of solar radiation is absorbed by the atmosphere, with 30% of the sun's radiation being reflected back into space. And that was ultimately it in terms of the greenhouse gases, albedo and latitude influence on the Earth's heat budget. Okay, it is a crucial concept in understanding the Earth's climate system. We know it's influenced by various factors, but by analysing the heat budget, we can better understand the complex interactions within Earth's climate system. In terms of lesson 9, it was depressions and anticyclones. This lesson here, very, very quick one. Anticyclones and depressions, otherwise known as cyclones, are opposites. So depressions are a low pressure system, also known as a depression/cyclone. They occur when weather is dominated by unstable conditions. Under a depression, air is rising, forming an area of low pressure at the surface. Because the air is lighter, this air rises, so it cools and condenses and forms clouds, so you get rainy, stormy, windy, cloudy weather. Anticyclone is the opposite. It's a weather system with high atmospheric pressure, characterized by sinking air because it's lighter, it gets heavier, it gets heavier, so it sinks downwards. It warms as it descends. This sinking action suppresses cloud formation, leading to stable, dry and settled weather conditions because there's no clouds. In the northern hemisphere, winds spiral clockwise around the high pressure centre, while in the southern hemisphere, they spiral anti-clockwise or counterclockwise. So cyclones can happen in low pressure areas like on the equator, in rainforests, in Southeast Asia, whereas anticyclones can happen where there's high pressure, for example over the Sahara Desert or over the United States, very commonly. So in terms of your case studies for these two topics, anticyclones and cyclones/depressions, we have Europe's heat wave of 2003, and we have the St. Jude storm in 2013. Both of them end with a 3, should be fairly easy to remember. So Europe's heat wave, I'm hoping you worked it out and remember that because it's a heat wave, there'd be no clouds, it'd be clear skies, the sun's solar radiation can come straight through, therefore it's an anticyclone. Whereas St. Jude's storm, for a storm over the UK, cloudy weather, we're looking at depression, okay, depression kind of weather. So in terms of the topic for this, you did your independent research, you filled in your table. As long as you remember some primary effects, secondary effects, responses, then you should be set to answer exam questions such as explain the formation and characteristics of depressions and discuss their impact on weather patterns in the UK for 15 marks. If you want to write an answer for that anytime, I will mark it for you. Alternatively, discuss the impacts of anticyclones on North American weather patterns. Again, maybe for this one, because it's the UK and Europe, you couldn't use that example, But if it was about anticyclones more generally, again, you could use this case study. Economic, social and environmental impacts. It'd be useful for you to break them down and have a collection of each. In terms of lesson 11, this was looking at monitoring extreme weather. Now, monitoring is quite a key definition. Monitoring is the continuous observation and collection of data about physical changes or human activities to understand and forecast future events, such as natural disasters, such as storms. This process uses scientific equipment, such as satellites, to detect warning signs of tropical storms, enabling authorities to prepare and issue warnings to save lives and mitigate impacts. As you'd expect, HICs can do this a lot better than LICs due to financial and technological advancements. There are many different places where this is happening. The National Hurricane Center in Florida monitors weather all the time because they have the money to do so. So more specifically, in monitoring tropical storms rather than earthquakes and volcanoes, you can use satellites and radars. This technology tracks the development and approach of a tropical storm. You can see where it's going to come and when it's going to be there. They have an effective hurricane monitoring system in the UK because, as I said before, they are a HIC, so they can predict. Therefore, the impacts should be, on average, less. However, don't forget there are physical factors at play here, and if the storm is simply stronger, it still can cause bad effects. Any preparation, any monitoring doesn't guarantee saving lives. But all tropical storm activity over the Atlantic and Eastern Pacific is tracked by this National Hurricane Center in Florida. As a result of the hurricane watch is issued when hurricane strength winds are detected to alert people and give them time to prepare. This is always published online. And in a place like America, the HIC, this information spreads quite quickly because of radio, social media, phones, TV, and not everywhere in the world has that. But low-income countries are going to be, on average, less prepared for tropical storms because monitoring equipment, like satellites, like radars, is expensive. But also, even if they can see when one is coming, not everywhere has access to radio and television, and therefore the ability to communicate is likely to be affected. So in terms of cyclones, monitoring cyclones is the same thing as monitoring depressions. So weather-related depressions are monitored using satellites and radars, but also buoys, in terms of the ocean buoys, not buoys from the class. And ground-based weather stations track the wind, they track pressure, and they track temperature changes when anything goes really slow to fast in terms of wind, or high to low pressure, or hot to cold, cold to hot temperature change. This shows up. Advanced computer models use this data to predict storm movement in direction, where it's going to be, but also intensity. In other words, how strong it is. This enables weather guys, or a more formal way of saying that is meteorologists, to issue timely warnings for heavy rain, strong winds and flooding that might come from such depressions. Don't forget, depressions occur in low pressure areas, low pressure, lousy weather, clouds, storm, wind, rain. People can also personally, on a personal level, monitor a depression's passage by observing changes in cloud cover, seeing where clouds are and where they're going to, and also monitoring temperature, wind direction, and levels of precipitation. So satellites, radars, weather buoys, and surface weather stations, as well as atmospheric and ocean models, you can also see maybe where future paths may come. In terms of personal level, cloud cover, wind, precipitation, temperature, and pressure. And this happens all over the world. In terms of the opposite, so monitoring anticyclones, is slightly different. Monitoring anticyclones involves tracking their location and intensity on weather charts, normally using algorithms and reanalysis data, like NCEP or NCAR or ERA5. Normally, what you're looking for here is pressure, its gradients and isobars, while the tracking itself involves plotting their positions at regular intervals on a continuity chart to understand their movement and evolution. Any words here, by the way, like isobars or gradients or parameters, please do pause, find the definitions from your glossary. If they're not in there, add them to there, and then come back to the video or podcast afterwards. So yeah, there's methods for monitoring anticyclones. There's manual tracking. In other words, what this is, it's more traditional, and you track migratory weather systems. In other words, anticyclones that are moving. Migrant is someone who moves, therefore a migratory weather system is a weather system that moves. So what happens here is surface analyst charts show the isobars, so the lines of equal pressure. They locate the centre of the anticyclone, defined by the isobars on the chart. They then plot the anticyclone position on a continuity chart, so over 12-hour intervals, and they then observe how the position changes over time and its progression across the landscape. You also have automatic tracking algorithms, so computers that automatically detect and track anticyclones from weather data. This uses the algorithms like NCEP, etc., and providing every 6 hours or so surface pressure data. How it's done is you detect, you then track, and then you measure the intensity through metrics, normally measured by pressure gradient within a specific radius of the centre of the storm. Surface and optic charts, continuity charts, and atmospheric reanalysis data. And why do we do it? Well, ultimately we monitor anticyclones as part of weather analysis to understand current and past weather patterns. Forecasting, you predict future weather conditions as anticyclones are associated with different weather phenomena depending on the season, and also climate change research, studying long-term trends in anticyclone frequency, how often they happen, and intensity and their impact on the climate, so how strong they are and how they impact the climate directly. And the final part of this podcast looks at lesson 12, which was the Sahel. Before we get onto that, we read some of the definitions for mean, median, running mean, trend, range, interquartile range, Spearman's rank, and mode. Mean being the sum of all the values divided by the number of values, median the quantity lying at the midpoint, the running mean is the method that calculates a series of averages from the subset, the trend being the general direction or pattern, the range being the gap between lowest and highest points, the interquartile range tells you the spread of the middle half of your distribution, Spearman's rank is a number to tell you how strong a correlation is between two sets of results, and the value that appears most frequently in a data set is called the mode. Okay. Now, in terms of the picture you see here, this is the Sahel, and this is where it is in the world. So the Sahel is your example of a drought event. Okay, you did some research on this in terms of the amount of rainfall the Sahel has got in recent years, and across parts of Morocco too, has gone down. Okay, this is due in some part to global warming. So the Sahel is across the nearly centre of Africa, the centre north, and it's just below, runs alongside, but below, parallel to the Sahara Desert. As you can see from the picture on this video, you can see that it's very, very dry. There are some trees though. It's not totally high pressure conditions, because don't forget, that's slightly more north of 30 degrees. The Sahel is slightly closer towards the equator, about 15 to 20 degrees. But yeah, ultimately, there are some trees, but it has experienced some droughts. The Sahel region has experienced significant variability in rainfall over the years, with a notable shift in trends. Since the mid-1980s, precipitation, rainfall really, in the Sahel has shown an increasing trend, with some studies indicating a gradual recovery from the severe droughts that did take place in the 1970s and 80s. Okay, now this had impacts on social well-being. When there's a lack of rainfall here, when there's a drought, but also when there's a flood, the Sahel can be impacted. It can have severe social, people, and economic, money effects, normally linked with agriculture and farming. Now, obviously, if the farming is affected, this will affect food supply chains, food security, and therefore prices may increase and people may go hungry, even starving to death. Now, these extreme weather events threaten the livelihoods of people in this region, especially with it being predominantly LICs. These people rely on their farming crop yields and the amount of money they make from these farms. So with growing populations, with soil getting worse, in other words, soil degradation, decreasing in quality, this is going to be a problem. For instance, the depletion of Lake Chad has had significant impacts on agricultural output, food security and social order in the Sahel. If you're looking for an example, Lake Chad is the one. But also it affects groundwater supplies and river discharge. So changes in rainfall trends affect groundwater supplies and river discharge. Studies have shown that increased rainfall in some parts of the Sahel had actually led to an increased river discharge. River discharge being the amount of water to pass through a point at any given time in a river. But with more water being in some places, you're going to have others experiencing a decreased river flow. If you're looking for more specifics, like I would expect for an A-level, the Niger and Senegal rivers have shown decreasing trends in flow due to the Sahel being dry and experiencing droughts. In contrast, as I mentioned though, other areas have actually seen increased stream flow and increased rainfall has caused that. In terms of the Sahel even further, soil moisture. Now that is crucial for agriculture in the Sahel. You need to have a certain amount of moisture in the soil to grow a good amount of crop and have a good crop yield. Now research suggests that the region has experienced influctuations of soil moisture. In other words, it's gone up and down over the years, and again it depends on where you are in the Sahel. Some areas show an increase in soil moisture content during summer. However, the relationship between the rainfall and soil moisture is complex, so wind speed, solar radiation and water vapour can take a part here. Sometimes some water is lost through transpiration, for example. There are economic impacts. Now, normally, droughts and floods can affect, as I said, agricultural production, so food insecurity, losses for farmers, and the region's agricultural sector is very vulnerable to climate change. This climate variability, the more extreme droughts / the more extreme floods, are very hard to adapt to, and even harder to mitigate to. So adapting is changing your methods depending on what is happening to you, and mitigate is trying to stop the process as it happens. Both of those are hard in LICs. So rainfall trends in the Sahel have changed over time. So since the 1960s to the 1980s, it has decreased since then, and we've had a gradual recovery. However, today, the region still experiences a high variability in rainfall. Areas in the Sahel, such as the one in this picture, are very prone to droughts, but also can flood as well. So you need to understand these changes in managing water resources and mitigating the impacts of extreme climate events as part of that. In terms of that podcast, that is it done for the week. Any questions, let me know. Any past paper questions you find, please do answer them. I will mark them for you. Otherwise, I'll see you soon.